welcome to the Florida Conservation Station podcast, where we bring to you the most important information on Florida's ecosystems. On today's episode, we'll be talking about a very important ecosystem by the name of estuaries. I'm Sophie, and I'm joined here with my two co-hosts.
I'm Brandi.
And I'm Justus.
Our goal for you after this episode is to be able to hopefully know what an estuary is, identify and describe key plants and animals important to Florida's estuaries, and understand major ecological threats and ways you can help combat them. For those of you who have absolutely no idea what an estuary is, that is no problem, because I am here to explain. An estuary is a tidal mouth of a large river where the tide meets the stream, which basically means where saltwater and freshwater mix. Lots of super important plants and animals rely on this type of ecosystem, as it provides a ton of resources such as crabs, shrimp, clams, and even manatees. In fact, estuaries are often called nurseries of the sea, due to the fact so many species use them as breeding and nesting grounds, such as salmon, herring, and even oysters. Another important function of estuaries is to filter out sediments and pollutants from rivers and streams before they flow out into the ocean, so they can make cleaner waters for humans and marine life. Not only do animals benefit from estuaries, humans do too. This ecosystem is important for human things like jobs, recreation, and homes.
I will be discussing a major threat to this ecosystem, known as eutrophication.
What exactly is eutrophication?
Why does it happen?
USGS.gov defines eutrophication as a natural process that results from accumulation of nutrients in lakes or other bodies of water. In more simple terms, estuaries are typically lower than the surrounding land. Therefore, everything that gets swept up by rainfall or wind ends up in either the ocean, a lake, or an estuary if you live close to one. So, this is a natural process. But what makes it not natural is when something like humans are causing this process to happen at an increased rate. The algae that naturally feed on these nutrients receive an abundance of food, and this is what causes an algal bloom. These algae blooms can change the surface color of the water, promoting high turbidity or lower water clarity, and they can even cause fish kills and shellfish kill. Some algal blooms can even become toxic to humans, such as Karenia brevis, aka red tide.
That's really interesting because I was actually reading an article about brown tide, which is another type of algal bloom. It's not actually a toxin producer, it just disrupts ecosystems because its extreme bloom concentration blocks sunlight and has led to the extensive die-off of seagrass, which is a vital estuarine habitat, with negative economic impacts.
Yeah, growing up near the Indian River Lagoon, we heard about red tide since I was like a child. There were times where the government would literally put out statements like, "You cannot swim in the lagoon right now." Like it's so bad to humans, and a lot of it is due to human interaction.
So yeah, many Central Florida residents may be familiar with what's happening within our local estuary, the Indian River Lagoon. Over the past few years, the IRL has experienced multiple brown tide algal blooms, which have affected numerous species of animals and plants that reside in the lagoon, including our beloved Florida manatee. Manatee are a keystone species. Therefore, by protecting them and keeping their populations healthy, we're protecting many other species around them as well.
Oh yeah, we've actually seen these impacts already in the last few decades, including manatees with unusual mortality events due to a lack of seagrass, which is their main food source. There are likely more negative impacts caused by the increased brown tides that we just haven't discovered yet.
Eutrophication is an issue many estuaries face across the world, largely due to an increased population and development along coastal communities. However, what if the Indian River Lagoon crisis could be due to something other than our population?
You're probably wondering how we got here. For that, we have to go back in time to the 1990s for a moment. Eminem was just getting his start, bell bombs were all the rage, and the Indian River Lagoon was still mostly clear, and seagrass was abundant. However, something important was happening that would change everything. The IRL was losing the majority of one of its most important filter-feeding species, clams. An average adult clam can filter around 3 gallons of water per day, which keeps the turbidity down and allows sunlight to reach the seagrass beds. These are the natural filter feeders that were keeping the water clarity issues in check.
However, the majority of clams were overharvested during the 90s, when this was still seen as a natural thing to do. Then, a decade or so later, we had back-to-back brown tide algal blooms that did not give the ecosystem a chance to recover. Scientists are just now piecing this together, and they're starting to take action to reverse these damaging effects. And with that, let's head on over to Whitney Laboratory with University of Florida to see just how these clams can filter the water.
This time-lapse shows a close-up of a 5-gallon aquarium containing 30 small clams about an inch in size. Once buried, green algae were added to the tank to simulate an algal bloom. The clams immediately start feeding on the algae through their siphons, which you can see protruding from the sand. As they feed, they eject green fecal matter, which deposits on the sand. 1 hour later, the water in the tank is clear, and sunlight is able to reach the seagrasses. But nothing goes to waste. The fecal matter on the bottom is now available for many other organisms to consume, such as these grass shrimp.
So one of the things I love about this video is that it shows the clams filtering the water, but also it shows that their waste that they create can also be used by the rest of the community in the ecosystem, like those little shrimps. Even though red tide and brown tide can be very scary for estuaries, this video does bring out a really good point, and that is, luckily, there is hope.
So restoration projects in the Indian River Lagoon have already been in effect for years. The most common of these involved planting new oyster and clam beds in areas where evidence has shown that they can subsist or records show they used to exist. Doing this is surprisingly simple yet effective. In many cases, an artificial reef is created by various means, such as sinking large amounts of stone or even old boats, piers, or docks, and placing breeding adults along the new bed in a process called seeding. These breeders can quickly multiply, creating flourishing reefs.
Oyster restoration is vital to estuaries worldwide that are suffering from impacts caused by eutrophication and other human-related impacts. We're joined now with the Nature Conservancy, who will be talking a little bit more about what they do for oyster reef restoration.
With partners and volunteers, the Nature Conservancy is experimenting with a variety of restoration techniques in the southeastern United States and around the world to see which works best under different conditions. On Sapelo Island, Georgia, the Conservancy and a host of government and academic partners are testing 2 methods of reef restoration along an eroding tidal creek bank. In one experiment, gabion baskets are filled with either rock, loose oyster shells, or bag shells and then embedded along the bank. In another, bags of oyster shells are layered and secured with untreated pine stakes. Both sites will be planted with native vegetation to help further stabilize the bank. With 8,000 bushels of shell needed for the project, staff and community volunteers have logged countless hours collecting and bagging recycled oyster shells. Since 2005, we have worked with the University of Central Florida in Mosquito Lagoon on the Atlantic coast. Boat wakes are dislodging oyster from their reefs, tumbling them into barren islands of oyster shells. Through extensive community support, more than 12,000 environmentally safe mesh mats have been tied with oyster shells, a technique designed to withstand wave activity. These are weighted to the bottom of the lagoon at specially prepared sites and connected to form a huge welcome mat. Free-floating oyster larvae settle on the mats and within 1 year produce the backbone of a healthy new reef. So far, 31 reefs have been restored and are now settled with juvenile oysters.
The location of these artificial reefs is critical and designed to be spaced apart in such a way that they intertwine and create a network allowing for population mixing and natural dispersal to increase the areas of the beds autonomously. Now, a much more difficult problem to tackle is the man-made pollution affecting the waterways that feed into these estuaries. Efforts have been made to track and map the sources of these pollutants and attempt to catch them at the source. Fertilizer runoff and unpaved roadways leaching into the waterways are being monitored to assess where targeted conservation efforts will be the most efficient. These efforts include reduction of waste, greener fertilizers, and ecological filtration such as oysters and clams, even mangroves, and reintroduction of tidal flushing. Tidal flushing plays a major role in the balance and health of estuaries. Tidal flushing refers to the movement of water in and out of the system caused by the flow of tides. Estuaries rely on a mixture of fresh water from the feeding river and saltwater from the ocean. The flow of salt water is especially important as it helps dilute pollution and pulls excess nutrients and detritus from the water. Damming, draining, dredging, and filling all affect the natural tidal movements and water levels of estuaries. Reducing our impact in these ways allow for the water to be more naturally balanced, especially in areas where pollutants are being constantly introduced. So you might be thinking of different ways you can help out with this major problem, and luckily, there are already great efforts being made towards solutions to this issue, such as the articles and projects we've discussed.
Additionally, we're going to throw up some resources on the screen for you to call or even volunteer at, as this can not only help the ecosystem, but also help your local community, and give you a chance to help your community firsthand. Each of us has picked a conservation group in Florida that we'd like to highlight for their impacts on estuaries.
The University of Florida's Whitney Laboratory, along with partners, are working to restore clam populations in the Indian River Lagoon. You can help their project by donating on their website listed on the screen. And here's a short video from the Whitney Laboratory describing a little bit about what their projects do and how you can help.
The University of Florida's Whitney Laboratory for Marine Bioscience has embarked on a holistic effort to restore Northeast Florida's oyster reefs to a healthy standard.
And the idea was to engage the public through citizen science programs to be a part of the restoration of oysters.
And their incredible filtration system helps keep our water clean. In fact, just one oyster can filter tens of gallons of water a day.
The pressures that create water quality problems are not going away. That's human impacts. And so we really need these guys to do what they do naturally to benefit us in our coastal ecosystems.
Problem is, oysters are being threatened by overharvesting, pollution, and very visibly by boat wake and anchoring.
And what has happened is the oyster shells themselves that were once in the water here through boat wake activity, they've been pushed all the way up on the shoreline. And in fact, they're piled up. We call them oyster rakes.
Once a healthy oyster reef is pushed onto the shoreline and turned into rake, the reef dies. There is no material for new oysters to attach, to form a new cluster, and no reef grows, allowing the relentless battering of boat wake to eat away at coastal property.
So oysters are protecting the shoreline from erosion, literally. And that protection can be translated to dollars when it comes to property values.
The material in the modules is plastic-free, easy to carry, and degrades over time, leaving behind no human fingerprint, and in 5 to 6 years, a stable oyster reef. Oyster larvae live in the water column for 2.5 weeks. These core modules, designed at Whitney Lab and built by community volunteers, provide a welcoming place for the larvae to settle and make a permanent home.
There are hundreds of baby oysters stuck to those shells. And they're going to grow into adults, and that reef structure is going to continue to expand as it goes.
Meanwhile, back here at the lab's hatchery and nursery, our ecologists collect local oysters and condition them to spawn. Then we give the oysters with spat, or babies, attached to the oyster gardeners to place in their gardens.
We give the oyster gardeners a cage with 20 to 25 oyster shells in it. They hang it off their dock, and they go out and they routinely check on it.
And eventually, after 8 to 10 months, you have a full cage of oysters.
So I love it, and I get to get out here. I get to check the water temperature, and we check the clarity of the water. I do that once a week. I do a quick look at the oysters that are growing in the oyster garden, try to keep up with a bit of a count about how many oysters I see on each shell.
More than 200 citizen scientists have participated so far in the oyster gardening project. Whitney Lab collects the thousands of pounds of live, matured oysters, and we move them to restoration plots.
And there's a lot of water to cover. So we want to recruit as many of you out there as possible to come participate with us.
We want to have an environment that people can live close to and near to and participate on, and not put them and their families at risk. So maintaining a strong population of oysters is good for not just the wildlife, but it's good for all of us here.
This area of Northeast Florida is currently home to some of the best water quality in the state. How long can we retain that status? We need your support to continue this important initiative. Contact the Whitney Lab to get involved.
Another lab that's right here on UCF's campus is the Coastal and Estuarine Ecology Lab, run by Dr. Walters. They're always accepting volunteers, and it's a great way to get outside and help our local lagoon. Your support of this project will help bring clams to the IRL with the goal of improving water quality and restoring healthy seagrasses to this important estuary in need of our help.
Another super cool program helping the animals of Florida estuaries is Save the Manatee, which are working towards protecting manatees and the habitat they live in. You can help them by simply donating, volunteering at one of their events, or even going to their website on the screen and adopting a manatee, where you can get to symbolically adopt a real-life manatee and even get a special handbook personally describing your manatee.
The last group we want to highlight on this episode is the Florida Oceanographic Society. They have been working to restore oyster beds in the Indian River Lagoon along with other conservation efforts across Florida. More information can be found at floridaocean.org. They do also have a really cool coastal center where you can take an interactive tour and see all of their current projects. If you're interested, you can donate and become a member on their website. These issues are a great reminder of our impact on surrounding natural landscapes. The future of estuaries worldwide will depend on how humans can learn to respect and take care of them.
Thank you for listening. Tune in next time for another Florida Conservation Station episode, where we'll dive into the warm waters of coral reefs. Keep clam, don't be shellfish.